Hi, this is Dr. Balraju Karri, the author, Inorganic Chemistry, Cengage, India. And in this video, I am going to explain you the complete roadmap of Inorganic Chemistry Part 1 of the 4th edition of Inorganic Chemistry, where we introduce this roadmap for the first time. Let us see the roadmap, how we are going to start with and where we are going to end in the 11th standard. In the beginning with, we are going to start here with periodic table evolution and the periodic laws we studied in 10th standard, and starting from Daubernier, and then a new land comes, say sa re ga ma pa dha ni sa, like octaves, and then Lothar Mayer, and then comes Mendeleev, and Mendeleev actually gives a very proper arrangement with atomic masses. Then then we change to atomic number and gets a modern periodic table. All these things already studied in the 10th standard. We're going to see here once again as a revision, and then we'll move ahead with electronic configuration and the periodicity, and how the electronic configuration of an atom has a direct straightforward connection with the periodic table. Like for example, in atom there is a shell, and in shell you have subshells SPDF. SPDF subshells are basically, you see in the periodic table as S block, P block, D block and F block, right? S subshell has 2 electrons and S block has 2 groups. P subshell has 6 electrons and P subshell has 6 groups. In this way, there is a great connection between the electronic configuration and the periodic table. Right, all these things we'll see here, and then we move ahead in the road and we see here periodic trends and reactivities, different periodic trends like atomic size, ionization enthalpy, electron affinity, electronegativity, all these things, and exceptions. Obviously, you know, chemistry means there must be exceptions in it. The exceptions of beryllium or boron, nitrogen and oxygen, all these things you will see here. And then we will move ahead with the chemical bonding and types, different chemical bonds, you know, covalent bond, ionic bond. There are also something called dative bond or coordinate bond you will see in the 11th standard. Ionic and covalent already has seen in 10th standard, right? Here you see a new bond called as coordinate bond or dative bond. So how this bond is formed, what are the conditions for it, and there are so many questions on that you will see in this particular topic. And then you will move on to the next topic called as molecular geometry and hybridization. Just like you have hybridization of different plants you do, and sometimes you have hybridization of, what do you say, the horse and a donkey and you get a mule, right? Kachar, they say kachar or kachar, like that. Like that we do hybridization of orbitals over here, subshells of, you know, S and P hybrid, you get SP hybrid orbital. 1s2p you get sp2 hybrid orbitals. 1s3p 1d sp3d hybrid orbitals. This kind of hybrid orbitals are formed. Why they are formed? What is the reason for it, and there is a need for it. All these things you will see here, and because of hybridization, different geometries called linear, trigonal, planar, tetrahedral, all these geometries and the shapes based on the lone pairs present on the central atom, all this hybridization, geometry, shapes you will see in this topic. And then you will move on to the next topic. There is bond parameters in the molecular stability. In the bond parameters, bond is there. A bond different parameters, bond order, number of bonds between two atoms, the bond length, and the internuclear distance between two atoms in a molecule, and the bond energy, amount of energy required to break this bond, right? All these parameters. And important is bond angle, the angle between adjacent bonds. How to judge who has a higher bond angle, who has a lower bond angle, and based on what factors we are going to judge theoretically, and how this bond order is going to affect the chemical reactivity. These all parameters we are going to see in this particular topic. And then after understanding this, you go ahead with MOT. Now because the bonds have formed, the molecule is done. Now MOT is molecular orbital theory. Just like atoms have orbitals, even molecules form their own orbitals. Once the molecule is formed, the same atomic orbitals they don't retain. They form molecular orbitals called ummo and bummo. It's anti-bonding molecular orbitals and bonding molecular orbitals. They are different energies, and how they work, all these things we will see here. And the application of MOT is, you can understand the bond order between any molecule, of course, atomic number or Z equal to number of electrons was less than equal to 20. For a diatomic molecule, you can find the bond order. And also you can know which molecule exists and which does not exist. These things also you can judge with MOT, and whether the molecule is paramagnetic, getting attracted toward the magnet, or diamagnetic. All these applications are very, very important from examination point of view. You will be going to see here in MOT. And after that, we are going to enter into the new chapter. Again, the block chemistry is going to start over here. Beginning with the hydrogen chapter. Hydrogen will be very special, you don't know where to put this hydrogen. Most often you see periodic tables, they put somewhere up and somewhere here, somewhere there. It's not clear because hydrogen has the properties similar to group 1 as well as similar to group 17. Alkali metals are halogens and some properties are against them, some are similar to them. A big confusion about hydrogen. You will see what are those confusions of hydrogens, why it is not placed properly, and ultimately it is being placed in the group 1. And the position of hydrogen is one thing, and then it forms hydrides. Whichever element to react to hydrogen, it forms hydride, right? It forms compound both with the metals and non-metals. So what is the behavior of these hydrides and what kind of hydride forms? Ionic hydrides, covalent hydrides, interstitial hydrides, and who forms this? And who are the exceptions? Beryllium, magnesium. All these things you will see in this topic, and then you move ahead. Very important compounds of hydrogen apart from hydrides, which are good reducing agents, is water and hydrogen peroxide. So hydrogen peroxide is unstable, because of which it decomposes to again water, giving out nascent oxygen. Because of nascent oxygen, hydrogen peroxide becomes a very good oxidizing agent. Not very good, but it's a good oxidizing agent. You can say mild. H2O is also used as a mild antiseptic. And water, water is two types of water: soft water, hard water. Hard water is not very hard, but it has so many minerals and salts in it, because of which it cannot be used for drinking purpose. How to convert this hard water to soft water, all these things we want to see here in this topic. And after learning all these things about hydrogen and its compounds, we're going to move on to the first block, that is S block. In the S block, we get the first group called as alkali metals, not anarkali, it is alkali metals. Group 1, that is Hey, Li, Na, Ki, Rab Se, Faryad, or you can say some mnemonic you understood like this. Hey, Li, Na, Kabr Se, Farar. This kind of element is hydrogen, sodium, lithium, sodium, potassium, rubidium, cesium, francium. The group 1 elements, alkali metals, what are their properties, physical properties, chemical properties? Are they going to react with oxygen? Are they going to react with nitrogen? If they react, what kind of compounds they form? Now we know nitrogen reacts with group 2 elements and form the respective nitrides: magnesium nitride, calcium nitride, strontium nitride. But this nitrogen don't react with group 1. Group 1, they do not react with nitrogen to give the nitrides. But of course, there are exception in chemistry. You see, lithium reacts with nitrogen to form lithium nitride. Why so? I say lithium is Lily and magnesium is Magubai. This Lily Behen and Magubai has an affair, because of which that is called as diagonal relationship. Because of which group 1 lithium is reacting with nitrogen like group 2 magnesium. There are many reactions like that, and if you want to know what are those reactions, to read this book, this chapter, and here we see all these things over here, and the different compounds of alkali metals and as well as alkaline earth metals. It forms different salts, important compounds of sodium, calcium, magnesium. We are going to see here and the properties, and then we move on to the last chapter of this particular book, part 1, that is P block. And in this part, we see only 13th and 14th group. 15th onwards, we are going to see in the part 2, is in 12th standard. See, in 13th, the most important element is boron. We see boron family, and these are electron deficient molecules, because 13th group, they have outermost 3 electrons. So the electron deficient, they form 3 bonds, right? 6 electrons, less than octet, electron deficient molecules. And boron has really amazing compounds, it forms diborane, and diborane forms a new kind of bond. You must have heard first time, it is called as banana bond. It forms banana bond. It is also called as 3-centered 2-electron bond. Likewise, boron has a very different kind of molecules. It forms an acid called orthoboric acid, S3BO3, and generally if it is S3BO3, it is supposed to lose 3 hydrogen ions, but it does not lose a single H plus ion. Still, it's an acid. How it is? You must understand here, right? So then we move on, after the special compounds of boron, you move on to the carbon family, and you see carbon is very famous. Carbon has allotropes like diamond, fullerene, and graphite, and most often students think the most stable allotrope of carbon is diamond, but it's not. It's graphite, right? You see all these in this particular chapter of carbon and carbon. Apart from carbon, even silicon is very important. Silicon you use in as a semiconductor device, and most of the electronics is because of silicon. So all these different compounds, silicon and carbon, the allotropes, isotopes, you are going to see in this carbon family chapter, and this is how you end the first part of the inorganic chemistry. The next video we will explain about the roadmap of part 2. Thank you.